So a very good afternoon to you guys. Today this is a very important lecture in this semester where we are going to introduce to you the electronics of building your robot. So I really hope that you guys are going to pay full attention. The lecture will be available later online if you want to review it, but I think here is the opportunity for you to learn. The task is not trivial, is quite sophisticated, but we have full confidence in both you as well as our instructor that we will eventually complete the task successfully. So today I have with me Mike. You know him, he's your instructor, and he's going to take you through the process. By the end of today, we hope that everyone will be able to use the Arduino board together with a computer to control an LED light. That is an extremely important milestone. Every one of you have to leave the room able to do this, because tomorrow we will continue working on the robot. And that's the time where we will work on how to control the motor. So this is really a key lecture for your success for the remaining part of the semester. Feel free to ask the question once, twice, and 3 times. There's no wrong question. The only wrong question is the question that you did not ask, the question that remained unanswered. So we are here to support you as much as we can to ensure your success. So with this, I'll pass to Mike. You give him a very warm welcome first.
Okay, good afternoon, everybody. So as Professor Mushtaq mentioned, this will be a 2-day thing, and today we will only handle programming LEDs and in a number of sequences and things like that. So before we start, can I just do a very quick checklist? Every group has their laptop with them, at least one. Who does not have a laptop with them or have any trouble with the software? No? Okay. Did everyone get 2 red LEDs that was passed around? Okay. Who doesn't have 2 green LEDs that was passed around?
So everyone has a laptop? The software downloaded in the laptop? Yes. Good. Then at least 2 red LEDs? Yes. 2 green LEDs? Yes. Okay. 2 black wires? No. Okay. So we need more wires. Yes. Okay, so more black wires will be passed. Please make sure that you have we have exactly what we have put on the screen. This is extremely important for the success of today. So you have 2 red wires? Okay, those who don't, we will pass more red wires. 1 plier. Every group has 1 plier. You will need this to peel your wires. Okay, so everyone has the Arduino board. Can you show them the board? You have some? Yeah. Could you have the USB cable? Okay, who does not have a USB cable? So the instruction was, you guys need to bring a USB cable, right? And if you don't have a USB cable, where do you get the USB cable from? From your printer. This is where we didn't provide you the USB cable. This is something that you have to bring, just like we asked you to bring your laptop. So you have a USB cable. Do you have a USB cable?
Okay.
So do you have the Arduino board and the breadboard? The breadboard is this. So everyone has, please pay attention. Every group has 1. Okay, good. I think we are good, Mike. Go ahead.
Okay, so today quickly we're just going to go through what we're going to cover today. We're going to go through the anatomy of the Arduino board and talk slightly anatomy and the specification of the motor controller. And then we're going to test your Arduino board to make sure it's functioning. And then we're going to do a little bit of programming today. Okay? So we'll just go through the Arduino board. If you look at it, the important thing you need to pay attention about is the digital in and out, which are these 13, 14, 15 pins on the top. Okay, these will be the pins that will send your signal and will provide the power for these things, your LEDs and stuff to function. And then your USB interface, which is what we're going to use today to do your programming of the Arduino. I marked also the auxiliary power down there, which is something you should take note of, but we will not cover yet until tomorrow. So just
okay, so
be
leave
aware.
this one first. In your group, please, in your group, take the board out of its box. In your group, please point to your colleagues. Where's the digital in and out? In your group, just make sure that you know which one it is. And if you don't know which one is the digital in and out, please raise your hand so that we come and show you. Okay? Kindly note the USB interface. Have a look at it. Just make sure that you have watched it. And the auxiliary power. So these are the three things that we would like you to be familiar with. Is everyone already familiar with that? Okay. So have you checked it? Yeah. So where's the digital in and out? Right. Where's the USB and the auxiliary power? Wonderful. Yes. So where's the digital in and out? Okay. The USB and the auxiliary power? Wonderful.
So now that we're clear on that, we'll move on to the motor controller. So some teams would have gotten a slightly different motor controller from the one I'm showing here, where the 4 pins from the two and two pins at the side will be moved together up here to become 4 pins. So there is actually no difference. It's the same motor controller, just that some of the things have just moved position. So the specification of the motor controller is kind of listed here. What you need to note is that you can supply anywhere from 4.8 to 46 volts worth of power into the motor controller for it to run the motors. But of course, you need to pay attention to the maximum amount of power that the motor can take. Like I said, there is 2 different types of motor controllers that you all might have gotten. Okay, some of them will look like this one that I'm projecting right now, and some will be slightly different. You will notice that the one that is different has no words on it.
Okay. So now, those who have a similar motor controller, can you please raise your hand? Okay, okay. Those who are not sure, raise your hand. Yeah, so please, so you are not sure. Okay, you please take your motor controller out of its plastic bag. If it is in the plastic bag, take it out. Please compare it. Please compare it to the motor controller that we have put on the slide here. Yeah. So please make sure that you open it. Yeah. Okay. You may need scissors, so don't injure yourself. Yeah. Yes. Yes. Don't injure yourself. Open that. Okay. You can use this. You can use the scissors, please. Please use the scissors. I don't think the plier is the right tool to open this. I'm serious, because you damage it, then it's going to have a negative impact on us. Can I get the scissors back, please? Thank you. Anyone needs the scissors? Yeah. Anyone needs the scissors? Okay. You guys managed to open it? Okay. Oh, you use your mouth, I could see.
The plier.
Oh, the plier, yes. Okay. So what we'd like you to do, guys, please pay attention. So we'd like you to do, compare it to the one on the slide. And those who have a different one, raise your hand. So you guys had a different one, different. That's only different configuration. It's exactly the same function. So you don't need to worry about that. Okay. Mike doesn't have the same voice as me. So I asked him to stand in the middle, and I'm going to help him with the presentation. So please pay attention to him, because he is the expert in this. It's not me, it's him.
Okay, the relationship between the Arduino board and the motor controller, you got to think about it this way, okay? You are the Arduino board, and you are driving a car, okay? The car is the motor controller, the engine specifically. So you are sending a command to the car to accelerate, so the Arduino is sending a command to the motor controller, and the motor controller or the engine will run the wheels. So it's the same thing. Okay, so some of the facts and figures there would come to be important later. For now, just think of it, just understand the relationship of these two items this way. Then we move on to the next item. So before we start programming, can everyone start their Arduino programs on their computer? And you have to see that screen appear. So can everyone just start it and show me that screen? Next step, let's connect the Arduino to the computer. Using the USB cable and then connecting to the Arduino and then the computer, you'll accomplish that. So has everybody done that? Okay. Yeah, next.
So I'll be the translator from Mike. So everyone, please take the cable, connect one end to the Arduino board and the other end to your computer. And that's all. Please don't attach any other things to the board. If we don't want you to unnecessarily burn your board, please. So please follow with us. Even if you know how to do it, kindly follow the process slowly. There is a reason why we are doing it in that way.
Okay, so the next thing I want you all to do is to open the Blink sample program. You can do that by clicking File, then Examples, then Basics, then Blink. So has everyone managed to start up? Does anyone have any trouble starting up the Blink program?
Anyone needs help, please raise your hand.
Yes. Yeah, but I just want you all to start it for now. Not load it yet. Okay, so now that everyone has loaded the program, could you just press the second button on the top, which is called the upload button? Just click that. Now, after your computer finishes running, could you all check if anything on your Arduino board is blinking?
We have 3 tables that you have issues here. You
So,
have
see this light that blinks? Yeah, so that means it's working already.
Mike, I think you need to make an announcement, but there's few people having this serial command is not found.
Yeah.
So for those who have a serial command not found, Mike is going to make an announcement.
Okay, everyone, just try clicking OK. If your board works, then it's fine. If it still doesn't, call me. Okay. So that's the case.
Yes.
That computer, download the 1.0.5 version instead of the 1.54. Yes.
This COM14,
Then it works.
what does it mean then down?
Yeah, okay, then that's fine. With these 2 lights down here, right, TX, RX, it means the signal is being transferred between the computer and the board. So yeah, so that means there's communication. Okay, that's fine, good. You need to download 1.0.5. Don't use this version because the new one is designed for another board. It's not finished yet. Yeah. So you have to close it and download the newer version of.
Do you know how to download the newer version?
Sorry, not the newer, the older version.
Do you know how to
The link is on Facebook. Okay. Can you guys expose the end of each wire by 1 centimeter? As in the red and black wires. Strip the rubber off it using the plier. Do you know how to do that? Just
do it one by one?
do it one by one. By 1 cm or so lah. If you accidentally, I have more wires. It's just that you guys should learn how to do this a little bit. Ruler can, but plier is faster, right? Okay, so you all have sent the code to make the LED blink on the Arduino board to the board, right? So the code that you sent is on the board. You will notice that it is a little shorter than what is written on the screen. That's because that the screen actually has a lot of the comments, which is actually unnecessary. You can take them out. They are just to explain what the codes are. So I'm just going to break it down for you.
So how do they know that this is a comment?
If there is 2 slashes or a slash asterisk, ending with another asterisk slash means those are comments. The program will automatically gray them out. Okay?
So the comments are there for you later when you program to put your name, some information about the program. They won't affect the performance of the program. So what is Mike saying? And anything that is slash asterisk, right?
Yeah.
Slash, that means the compiler will deal with this as non-relevant thing. So it's only useful for us as programmers to write this comment, so later we know what version, what date, and this program is to do what. And some people will put their name there just to attribute it to them. So what is on the screen is really the gist of it, the part that will really be used by the computer to send the commands and control.
Okay, so remember the reference that I made about the car, you being the driver? Okay, so now think of it as we are programming a driver. So you as a person, you know that this is your left arm, this is your right arm, and things like that. So what you are doing now in the first place is to tell the Arduino what is the left arm, what is the right arm. So you start with the top line, which is int LED equals 13, if you look at that, which means that you define LED to be port number 13, which in your case would be the blinking LED. Okay? You will see that you have also a pin number 13 directly above the LED. They are actually the same port. They share. So if you plug an LED into pin 13, they will blink together with the LED on the board. Everyone clear?
Maybe you need to repeat that.
Okay.
So what you are saying is that pin number 13, did you guys look at the Arduino board? Okay, you see the blinking LED on the board. It's next to which pin? Pin number 13. And so what Mike is saying, because you are putting pin 13 there, that's what makes it blink. Am I right?
Yes.
Yeah. So please pay attention to the fact that this is pin 13. So it means that there is now some signal at that port. And if I were to put another LED there, it will start blinking as well. Okay, so we just want you to pay attention to this fact. So this is 13 because it refers to the pin number.
Yep. So the next part, you would see void setup, pin mode, LED output. So what this actually means is, okay, this whole section, this void setup, and then the open bracket, and then the closed bracket at the bottom, this whole section defines what the engine would do, what the driver would do when he gets into the car, you know, when he wants to start driving. So this means that the board will execute it the moment it powers up. It will define that your particular pin number 13, is an output, or it can be an input. Okay?
And Mike, this is the part that is making it blink?
No,
Okay.
not yet.
Okay.
I need the board. Confused.
Okay.
Yes, like that. So it blinks together with the one on the board, right? You took the power, not enough power already. So,
Mike, do you want me to do this experiment? I think this will ground the...
okay. Okay, guys, everyone take one of the red LEDs. Okay. Plug one of the legs into number 13 and the other leg into the port mark GND.
GND starts for ground.
Yes. If you plug it in and it does not blink, that means you're plugged it in the wrong direction. Flip it around. If you plug it in the wrong direction, it won't blink. There will be no light.
Yes.
Okay. Now, I'm not sure if you all remember which is the positive and which is the negative for an LED. Okay, but an easy way to remember it is, if you look inside the LED, there's one that looks like a flag, right? And the one that looks like the cutoff of a flag. The one with the flag is the negative. And the negative should always go to the ground. Okay? Some of you will notice that the LED on the board will either continue to blink or will do so very faintly. That's because you took the power by plugging in another LED. Okay? So does anyone have any trouble making another LED blink on the board? He's changing the codes already. Okay? So the next part is the important part. Void loop, and then there's another open bracket. So this part is the part where the board will repeat continuously as long as the board is powered on. So think of it as your brain automatically handling, like when you see a left turn, you will do the left turn and things like that. So your brain is constantly aware of these facts, and this is what you need to tell the board to be aware of. Okay? So you'll notice that we start with digital right, LED high. So high and low, they mean the voltage level. Okay? So to think of it in the easy way, high would be on, low would be off. Now the case of these highs and lows are important. They have to be written in entirely uppercase. If you write it high or in lowercase, the program won't recognize it. So if you get an error, check your case. Check your commas and things like that. So after it says high, it says delay 1000, then another comma. So delay 1000 means delay 1000 milliseconds or wait 1 second. So during this period of time, the board will not do anything but just wait. Okay? That's why your LED stays on for 1 second. And then the next one, it says LED low. So it will turn off. It will wait 1 more second, and then it will loop. Okay, since you all have already connected one of the LEDs to port 13, can I ask you to connect it to port 8 instead? And then, can you modify the code to make port 8's LED blink? You have to send it. Every time you change something, you will have to upload it. Yeah, because now, I mean, what this program does is it translates all these things that you type into ones and zeros for that thing to understand. So when you change something, you have to compile it in and you can send it in. So, I mean, this is actually a connection board. So there's 2 lines here. The connection goes across like that, right? And these goes like this. So when I want you to plug like multiple LEDs, you're not going to want to put like 5 or 6 into the GND, right? So you move one over here and then you plug it here. So we'll go through that later. Actually, what you need to do is you need to define a second line. You have to define one more line. So INT, maybe LED 2 equals to something else. So it doesn't, I mean, I get what you're trying to do with your 8 colon 13, but no, it doesn't, because you can only define one. Keep the semicolon. Okay.
We need to keep the part of wire.
Okay.
So now we need to write
up there, not down here.
Okay.
So it has to be in the correct sections.
Here.
Yep. Next line, and then you write.
Enter.
INT LED 2 equals to something else. So can everyone take out their breadboard? That white thing.
The breadboard, this one.
Okay. So this board is what EE students typically use when they do electronics projects. It's to help them quickly establish circuits instead of plugging everything together. So, so to use it, you gotta first understand how this thing is wired. Okay? If you look at the breadboard, you have 2 thin sections on 2 ends and 2 fatter sections in the middle, right? So the fatter sections, they are wired vertically, as shown on the PowerPoint slide over there. And the thin sections are wired horizontally. So to make things really simple for you all, we are not going to use the horizontal section yet. We are just going to use the vertical sections. So this would come in handy when you're trying to connect multiple LEDs to the board. So you can imagine in such a way that if you connect ground here, everything that you connect here would be connected to ground. Okay? So in essence, you can connect 4 LEDs here and connect the ground to the board.
Okay, so now if you want 8 grounds, what should you do? If you want 8 ground instead of, this one gives you 4 grounds, right? Or maybe 1, 2, 3, 4, right?
Go down.
Okay, so connect this, but this is not connected. So you have to connect this to this yourself. With a wire. Then this will make the entire thing ground. Black or red won't make a difference, as long as they are connected. Okay, so this is how the concept of breadboard works.
Okay. So we're going to connect more LEDs to the board. So we can start with first connecting these wires to your breadboard. You are not going to have enough wires. So you can either cut them in half and strip them again, or you can come and get more wires. Up to you.
So this is connected horizontally. We are not going to use it this time, so we are going to focus on this. Yeah, with both horizontal and vertical, it will allow you to do more combinations. But for this, we will just want you to connect the ground to 1, so this becomes all ground, and then connect 7, 8, and 9 to the adjacent 3, and we will guide you through how to put multiple LEDs on this and control them at the same time.
So, is everyone done connecting the Arduino board to the breadboard? Okay. No one has any issues? Next, you can connect the LEDs to the breadboard. Whoa, that is odd. Why is everything blinking together? Because you
connected everybody in series.
I want you all to connect it with multiple ports. 8, 9, 10.
No, but if
Yeah.
you connect to 8, 9, 10,
Yeah, then I will ask you to write a program to make it light up in sequence.
like it should be on the same GND or 8 versus.
Same GND. So
How come you
8
can
GND,
fix-
9 GND.
How you can fix like 3, 4 wires in one?
Yeah, see that's the thing. You move. That's why you need the breadboard. When you move this over here, this whole line is GND, which is what actually you're doing right now, right?
Okay, so I can move it just
So
move
I
back.
just want your signals to come from a different port. Your plus to come from a different port. Your minus always go back to ground.
Wait.
Hi. Yes. Sorry.
Right, so how are we meant to, I think we've defined that.
Yeah.
Do we have to,
So okay, what you've done here is that you've made 3 loops, right?
Okay.
So you don't actually need 3 loops.
oh, okay.
You just need 1 loop. So you can delete the lines in between. What you did is correct actually, but you just need to get rid of the lines in between, the loops, and the void loop. That line.
And then close it off there.
No, as in these 2 lines. You have to get rid of those as well.
And the gaps here.
You can leave the gap. It's up to you. So.
Outro.
Okay? Yeah. So that's it.
For tomorrow, for you guys to learn, you will need 4 batteries and a motor. Any motor will do. If you guys have purchased something for your robot, just bring that along. If you haven't, any motor from a toy, whatever will do. We want to show you how to make the robot, the motor turn clockwise, anti-clockwise, on and off. These are going to be very important when you build your robot. And also bring some tape to put the batteries together, because we will need to make a battery stack. Now, if anyone has the holder that makes the battery stack, bring that, but it's not essential. We can make it here with some, we will connect them in parallel or in series, and we will teach you how to do it. So please try to bring these so that the learning experience is achieved. Okay, so I will leave you now, and I think Michael will still be here just in case you have any questions.